Everybody. So let me recap what we have done with the last 2 days, right? So we have done with the purpose of networking, right? We have seen that what is the purpose of networking. The major, I'm so sorry. So the major purpose of networking, guys, please be on the mute. Okay, so the major purpose of networking is was to exchange the data. Our data could be anything, right? The MP3 file, the text format, even you are sending the email, that's called other data. The types of traffic we can see that like unicast, multicast, and broadcast. One-to-one is called the unicast. Broadcast is a one-to-one, and multicast is a one-to-group. A WhatsApp group is a very good example of the multicast. Then after that, we have seen that what is the use case of IP. So the use case of IP is what it identify the location at the same time identity. We have a different classes of the IP addresses, class A, class B, and class C. That's for the unicast and broadcast. Whereas if I talk about, right, the class D and class C, the class D is totally dedicated for the multicast. Right, class E is reserved for the documentation purpose. Some books written like a documentation purpose, some books written like a future extension, right? So don't confuse with that terminology. One thing that you have to make attention, right, about the IPv4 addresses. IPv4 addresses are separated with the help of dotted decimal format, right? And the range of the IP addresses we have is 0 to 255, right? Each IP address has a subnet mask information. That subnet mask information will tell you how many host person and how many network person we have. How many host person we have in network, right? So that's a use case of the subnet mask. Every classes has a default subnet mask information, right? If I talk about the class A, we have a 255.0.0.0, right? That's a default one. Class B has a 255.255.0.0, and class C has a 255.255.0.0. That's a class C, right? So if I talk about like, which classes you're going to use to implement in your network, it's depend on the requirement. If you have a big cap, you can go with the class A. If you have a small cap, go with the class C. In a subnet mask information, the 1 is going to represent that's a network person, and 0 is going to represent that it's a host person, right? Don't worry, you will understand this meaning of this line, okay, when I'm going to discuss about the subnetting. Okay, so wait for the 1 more day or maybe the Monday. If you understand right now what is the meaning of one means network, that's you can see that this person is a network, and remaining all the person 24-bit is a host. So now you can imagine that, like, if you see the 2 to power 24, this range of the IP addresses we have in the class A. If I talk about the class B, if you see the 8 plus 8, 16, this range of the IP addresses we have 65536, I think so, right? So this range of the IP addresses we have, we just need to manage the two because the one is going to represent that's a network ID that you cannot assign to the any host. One is going to represent as a broadcast ID, right? Check the calculator because I'm not very, it's maybe the for 35 or maybe the 36 and broadcast ID. Remaining after whatever the IP address will be left, that will use for the host. And if I talk about the class C, we have a 2 to 8, right? We have a 256, right? Normally we have a range of the 255. So you have to start with the 0 to 255. So in that one, what happened? You need to leave the two, one for the network ID, one for the broadcast ID. Now you have a 253 usable IP addresses in the class C. So take example, if you have a 10,000 user, if you have a 10,000 user, you can go with the class B. If you have 100 user, go with the class C. That's a simple example I can tell you. Right. Then after that, we have discussed something, yeah, about the devices, right? Whatever the devices we have, right? Host, PC, computer, servers. Server is nothing but it's just a powerful computer. Hub, we have a device, switch, and router. So basically, these all my devices are used for the LAN communication, right? So maybe you have a question, hey, Law, how about the layer 3 switch? Do layer 3 switches use in the WAN communication, right? You can use in the LAN too, right? That we'll discuss in the future classes. But if you have a question in your mind, okay, you are talking the switch is layer 2, right, in the LAN network, but I have seen the layer 3. So I'll just let you know if somebody have idea. We'll discuss the layer 3 switch as well. But right now we are discussing of the pure normal behavior. So normal behavior, this is the LAN and this is the WAN, right? And apart from this thing, I think so we have covered everything, right? MAC address, we have seen that 48-bit address at the hex format, known as a different names are there, burn-in address, physical address, because why we call as a burn-in and physical address, because it's a burn on the NIC card. So during the manufacturing, what happened, the companies or organization putting the MAC address on the NIC card, and you can see that address. That's why it's called as a physical address, because it's present on the hardware. Whereas the IP address is known as a logical address. The reason is behind the logical means what? You can see that, but you cannot physically touch it. That's the meaning of logical. All done. So that's we have done. So let me show you the some labs of this one, how you can use the Cisco Packet Tracer. Let me open my Cisco Packet Tracer. Okay, I'm so sorry. I forgot to ask. If you have any question of yesterday class, right, then you can go to ask the question. Also, if you guys remember that I have discussed this thing too, right? What we call yesterday, I have explained you the very real life example. Take example, there's a guy, right, whose name is Anil, right? So, Anil is right now in the HSR layout and they wants to go to the Kodmangla, right? So this is the location in the Kodmangla, right? So this is the Anil is present over there in the HSR layout right now. So what he will do that he don't have a he doesn't have any bike and car right now. So what he can do, he can take a help of the bus, right? So what Anil will do, Anil will sit in the bus, right? This is the driver, right? And Anil will sit in the bus. And then after that, what happened finally, Anil can travel from HSR layer to the, right? Finally, Anil can travel from HSR layer to the Kodmangla. So basically, this bus, right? This bus is known as a media. So with the help of bus, with the help of media, we can travel from one location to the another location. Your train is a media. Your motorbike is your media. Your car is a media. Your bicycle is a media. Your skateboard is a media. So these are the media who can carry your luggage, right? Who can carry yourself as well, right? Even if I talk about right now, take example, we are communicating right now. This is communication is happening through the wireless. So here the wireless will become the media. Your Wi-Fi is a media. Same thing I have discussed yesterday, right? So on networking, we have we are discussing about the routing and switching, or we can call it the enterprise. In enterprise, basically we are focusing on the wired media because it's a totally a wired technology, not the wireless technology, right? So in the wired technology, what happened? We have a different cables. Mostly, if I talk about you can see the Ethernet cables nowadays. In an older time, we had something called as a serial link, right? But nowadays we are not using the serial link. You can encounter the serial link somewhere like a very rural area or very older very older topology they have, a very older network setup they have. You can find the serial link, but nowadays it's not recommendation to use the serial link. The reason is that it's a slow. The maximum speed of the serial link is what? It's near around, it's not exact, it's near around 1.5 Mbps, right? That's a maximum speed of serial link. But Ethernet, we have a 10 megabits to the up to the 400 gigabit. That's a speed of the Ethernet we have. So we have a different types. So we have a Ethernet, we have a fast Ethernet, right? We have a gig Ethernet, we have a 10 gig Ethernet, we have 100 gig Ethernet, 400 gig Ethernet. So these are the cables. This cables is known as a media. It means that with the help of this cable, right? Because technology is a wired technology, right? It's not a wireless technology. We are focusing on the wired technology, right? So in the wired technology, we need to take a help of hardware devices. And these are the hardware we have. And these are the media. So through this particular cable, right, we are transmitting our data, right? So whatever the data you have, normally, what happened? Uh, your computers only understand which language. Your computer only understand the 0, 1, right? The binary. So normally what happened is if your computer is sending the any data, for example, he's sending the hello, this is uh carry, right? So this is the information that you can read because you are the human being, right? You have designed the alphabets, you can read it. But normally the computer cannot understand this is a carry. So what he will do, they will convert this data into the 0, 1, 0, 1. And this 0, 1, 0, 1 will be travel over the Ethernet, right? In the bit of signal. So what happened? So when you're transmitting the signal from one end to the another end, the receiving end, what they will do that? They will reconvert the signal into the data. So what I can do that, let me explain you like how you can use the Cisco packet tracer, right? So I hope everyone has a Cisco packet tracer. If you don't have a Cisco packet tracer, do let me know. I can help you to install that one. It's a very basic to install it. You just need to go on the Google and search the Cisco packet tracer. You can easily get the bunch of link. Okay. And you can simply install the Cisco packet tracer in your laptop. And there's no many hardware requirements for this one. Even if you have a 2 gig RAM, you can have a Cisco packet tracer. And I'm telling you this tool, right? This simulation is an amazing tool, right? Like, for example, if you're doing the CCI lab exam, if you're going to the CCISP or even data center, right? And somehow you forget your basic, you want to see that how the packet is following from the one PC to the another PC, and how the packet is flowing between one router to another router, and how the packet is flowing between one PC to the another switch. You can see from the Cisco packet, so which is not possible in other simulation like EBNG, GNS3, WebIOU. It's not possible to see the actual packet flow in that simulation, but you can see in the Cisco packet tracer. So I personally recommend you, right? Try to use Cisco packet tracer at the CCNA level. Okay. Do not use the GNS3 or EBNG. And even somehow, if you are forget some concept, try to do the practical on the Cisco packet tracer and try to analyze the packet. So you can see that in this Cisco packet tracer, there's a file, something called as, right? You can open the new file. Okay. And if you already have saved the file, so you can open from here as well as, right? And then you can save the file, whatever the like a topology you made it, you can save the topology in your local system. And later on, if you want, you can open it. And then after that, if you want to change the like a size of the text, you just need to go in the options, right? Sometimes some people feel like, okay, this text is very small and like a big, and the background color is different, right? So you can go in the options, go in the preference, and you have options of the multiple things like a font we have, right? You can change the font. If you want to change the color of the text, you can change the color of the text. iOS background, if you want, you can change it. So it's not a rocket science. It's very simple. You just need to give some, 1 hour. That's all. And after that, as I told you that we have a multiple types of devices in networking, right? So mainly if you see, we have a different types of router, right? You can see that if you click on the routers, this section, so you can see the multiple different models. We have a router types, right? We have like it's very small 1841, 1941, like a 2811, 2901. Now, maybe right now, like, which router should I use, right? For the practical. So what I can recommend you, right? You can go with the either this one, 2811, or either you can go with the 2901. You can use any of the router, but go with this one because this router has a fast Ethernet link and a gig Ethernet link as well. Okay. Now, when you become an expert, right, then you can find, okay, which router is good for your network. That comes in the designing part, because in CCNA and NP, right, you need to understand the technology. You need to you have to become the familiar with the words, and the devices. Later on, if you have a expertise, right, in the routing protocols, in the switching protocols, and IP addressing and everything, right, then after that, you have to do the research on the particular router. And then you can suggest, okay, I have to go with that router, and that router is suitable for my network. So here you can take a routers, right? And then after that, you can see that we have a switch as well as we have a different types of switch. Go with the 2960. This is the switches we have. These are the layer 3 switches, right? That we'll discuss later. So these are my layer 2 switches we have over there. And then after that, you have a hub as well. Nobody is using the hub in the market right now. Okay. But again, Cisco Packet Tracer is giving you the option to use the hub as well. Then after that, you have a wireless devices, right? No need to do the practical of this thing, right? Because we don't have it, this thing. It's a totally a separate track we have with the wireless. Then we have a cables right over there. So you may have a question, which cable should I use? So normally, you know, a very simple way I'll tell you. If you have a same device, right? If you have a same device, like a switch to switch, right? If you have same device switch to switch, then you can go with the crossover cable. So you can see this cable, crossover. Okay. If you have a different device, like for example, you have a switch and then router, then you have to go with a straight cable. This one, or this one, this one. This one is a straight cable, this one is a crossover cable, this one is the fiber optic cable, right? So you may have a question, oh, what is the difference in the fiber optic and Ethernet? So normally the fiber optic, right? So fiber optic is used for mainly the major use of the fiber optic is what? Is for the distance perspective. So Ethernet doesn't allow you to give the more distance. Fiber optic allow you to give the more distance. Now, so what I can do that normal things, I'll show you how to configure the IP addressing on the PC side. You can take a end host from here. You can see that it's an end device. So whatever the servers, your computers, all this comes in the end devices, right? These are my security devices. So leave that part because we don't need to discuss about the security, but these are the ASA firewalls we have, right? So leave that part. We are not interested. Go with the end devices and take a whatever the devices you need. Maybe if you need a computer, you need a laptop, you need a server, you need a IP phones, you can take it. So take example. I will take the one computer. Okay, you just need to click on this computer icon and just drag and drop. Okay, then after if you need a second PC, just click on the same one and drag and drop. If you need a third one, just click on this one, drag and drop. If you need a laptop, just click on the laptop and drag and drop. Now, for example, if you want to, you know, put the 5 to 6 PC over there at the same time, right? What you can do that? You can just put the shift and then press the key over there and then put the right click. Okay, why it's not working? Hold on. Nice. So we were. I know somehow my shift is not working with this one, but it's working. So you can select the like one of the device and use the shift key, and then you can put the over there. And if you want to delete something from, like take example, I have a multiple laptops over there, multiple PCs. If you want to delete something, you can take a cross sign from there, right? Just click on the cross sign and delete this guy, whatever you want to delete. For example, laptop 0, laptop 2, laptop 1, laptop 2, laptop 3, laptop 4, laptop PC 4, PC 6. I can delete it. Even if I delete the PC 5, I can delete it. So this is how you can delete something, and then you can put the again. If you see over there, this is the cursor sign. You can just click over there. That's fine. Now, if you want to put something, if you want to write something on this dashboard, you just need to click over here, right? And then press over here, and then you can write anything. For example, I can write the IP address for this guy's 1.1.1.2. That's like I want to define it. Same way, for example, I want to define the IP address for this guy's 101.103. This guy, I want to define the 101.101. So I can define it, anything. And after that, what happens, still you can see that this is giving you the option to write something. But if you want to use the cursor sign, the mouse sign, then again, you have to click over here. That's all. After that, if you want to take if you want to diagram something, you do have option to draw something, like take a circle, draw line, draw rectangle, and then polygon as well. You can draw it. For example, I can make this guy in the fill a color, right? If you want to fill the color, you can fill the color. Otherwise, the default option is a no fill color. I'll fill the color. So take example, let's make the green this guy, and this one. I'll take another color for this guy, select another color. I'll make this guy's a PC2. Right? I'll make this guy a different color again. Blue, PC3. Why it's not coming? Okay. And then after that, I can take the another PC one. Take example. I'll take the more PC. I'll take all the, and I'll give this guy as a different color as well. That's not coming. My packet tracer is a very older, guys, I'm telling you. So you can download the new version. Okay. Mine is a very older one. Okay, that's perfect. So this is how you can draw the, sometimes when the people are fresh, right, they want to draw something on the Cisco packet tracer, and it looks good, something and so now there's something is called what? So now how do I connect this PC right now? Right. So what I can do, the first of all, right, I cannot put the multiple cables, right? I cannot add the multiple cable like this way. Because in this case, what happened, guys, please pay attention. In this case, what happened, it will create the cost, right? So I have to put the multiple cables to the PC. So can you see that? What's happening? How many cables we have? One cable, two cable, three cable, 4, 5, 6. Total, we have a 6 cable. That's a totally wastage of, money. At the same time, how many cables you can put on the laptop side? How many RJ45 cable you can take it and connect it on the laptop? Take example, if you have 100 devices, like it's not possible to connect all the 100 devices like this way. So what option I have, right, in a 90s, 80s time, Cisco said, hey, one thing, not Cisco, the requirement comes in the picture to connect the multiple devices. So they introduced the hub over there. And what is the use case of hub? Nothing. They just, put the cables over there from PC to the hub. That's all. Plug and play. That's plug. Okay, this is the control, not the shift, guys. It's a control. So now it's working. So I'm not putting the cable type. It's working now. So now I can connect this, all the cable. So right now you can see that previously my topology was something like this way, right? But now my topology is something like this way. A simple one. Let me define the IP for this task class. So 101 or 2. Now you can define the IP address on the PC. For example, I want to define the IP address on this PC. I just need to click on this PC, right? And you will see that I have a multiple option. We have physical, config, desktop. Just need to go in the config section, right? Not config, desktop section. And in the desktop, what happened? I just need to click on the IP config. So you have multiple options. You can see that you have a CMD as well, command prompt, that your normal command prompt that you have in your normal laptops. You just need to go in the IP configuration. You will get to know that each and everything's right, days by days, right? Whenever you do the lots of practical, the advanced level of the practical, you can see that the use case of each and everything. Okay, then you need to go on the IP configuration, and then you can define the configuration IP addresses. So the normal behavior is what? It's you need to define the static IP addressing. So the way you can define the IP address in the two way, either you can define in the DHCP, that's a dynamic. We'll learn this thing in the coming lecture. But the default behavior is what? You need to go with the static. Static means what? Manual configuration. Manual means what? A network engineer comes in the picture to do the IP configuration. It means that I need to go on this PC and say that, hey, the IP should be 1.1.1.1.1. Based on the first octet, what I told you yesterday. Based on the first octet, you can identify this as the class A IP address. And the default subnet mask will be what? It's 255.0.0.0.0. So what is the network ID for this guy? If you see 1.0.0.0/8 we are using, right? So this is my network ID. Okay. .255.0.0.0. This is my subnet mask information, which is also known as a CIDR value, classless interdomain routing. So this symbol is known as a CIDR value, right? This symbol is known as a subnet mask information. So in this network ID, I have this range of IP addresses. So I can put the 1.1 for this guy. Same way I can put the 1.1 for this guy. Just need to click on this icon, go in the desktop, IP configuration, and 1.1.1.2. Same thing if I like to define the IP for this guy, PC3, you just need to go on the desktop, IP configuration, 1.1.1.3. That's a default subnet mask. If you want to change, you can change it. I can change it. But you will get to know that like how when you have to change it, right? Wait for the subnetting, then you will understand this thing. And the PC4, I have a 1.1.4. That's simple. Now, what I told you that this is how you can configure it. Normally, if you want to verify your IP configuration, what you have to do in normal PC, you have to go under the command prompt. So you can click on the command prompt over here, right? And you can see the configuration of the IP as well. That's IP I defined on the PC1, right? That's a 1.1.1.1. So right now the network engineer is sitting on this guy, right? And he has defined the IP address on this PC 1.1. The subnet mask he defined, it's 255.0.0.0. Forget the default gateway, DNS server, DSP server, leave it right now. We'll discuss. After that, you can see that this PC has a physical address, which is my MAC address. The physical address is also known as a MAC address, right? And this IP address is known as a logical address. Same thing, if you're now verify on the PC number 4, right? You just need to go in the command prompt and put the command ipconfig /all. (1.1.4) and subnet mask information, right? That's a default one. And this is the physical address we have. Now, what I told you yesterday, if you guys remember that, the hub, right? It's a layer 1 device, right? Works on the physical layer. Second problem with the hub is what? It cannot understand unicast, multicast, and broadcast. Hub does not have ability. This is the guy. It's a very dumb person. It's very dumb person. He doesn't have any idea, right? How to identify the packets. So normally what hub will be do, right? So when you're sending the packet, take example from here, right? it will receive the signal on this particular port, and it will just regenerate the signal on the different port. My source is what? My source is PC1 to the PC2. So actual the packet should be like this way, right? Actual the packet should be like this way. But the problem is what? But the problem is what? If I'm sending the packet, the unicast packet, this is my unicast packet, but still what hub will be do? Hub doesn't have any idea of the unicast, not even the multicast, not even the broadcast. Whenever the hub receive a packet, right? Whenever the hub receive any data, it will just do the broadcast. And that's why we call as this is the dumb device, right? Because this guy doesn't have any idea. This device cannot identify the IP address. This device cannot identify the MAC address. So whenever it receives, it just transmit it to the every ports. So take example, if the hub has 100 devices connected, take example, this is the hub. And I have a user sitting behind the hub. And what happened? We have 100+ user, right? In this case, what happened? When this PC will send any traffic, all this 100 user will receive the traffic. If this PC1 is going to send the traffic to the any other PC, maybe take example, if this is sending the traffic to the PC number 2, right? So normally the agenda of this PC1 is what? He need to send the traffic to the PC2. But because of the hub problem, he will broadcast the packet to the every person. So there is no security in the hub. At the same time, try to understand what's happening over there. It's a wastage of bandwidth. How the wastage of bandwidth? So normally take example, if the PC1 wants to communicate with the PC2, right? The packet comes on the hub. What hub is doing that? He will send the packet to this guy. At the same time, he's sending the packet to this guy as this guy. So it's a totally wastage of bandwidth of this particular link. And this link as well. So every time, right? Every time you have a wastage of bandwidth. And that's why the hub is not recommendation to use. Let me show you this thing first of all. What I can do that from the PC1, right? Before you want to exchange the any data, right? Before you want to exchange the any data, in networking, what happened? We need to first verify the connectivity. Normally, let me tell you, let me explain you. What happened? Take example, I'm gonna make a call to the right Puneet, right? So take example, this is the law and this is the Puneet, right? And I want to make a call to the Puneet. So what I will do that directly, I cannot say that, hey, I'm transferring the $500 to you right now. I cannot say that directly. I will first use the keyword is known as a hello. So if I say the hello, and if the Puneet also will say the hello, it means that my communication is fine, and now I can exchange my data, right? But this hello is a mandatory. Different countries, different cities have a different words, right? But this is the universal word hello. It's not like that, directly I can send the data to the Puneet, right? Okay, I'm transferring the $500 before asking anything. We need to first confirm it, like my communication is stable or not. Same thing in networking, what happened? Before sending the any data between the PC1 to the PC2, what we have to do, first we need to identify the connectivity. Do I have a connectivity between the PC1 and PC2 or not? If we have, then I can send the data. So to verify the connectivity, we have a protocol is known as the ICMP. To verify the connectivity, we have a protocol is known as ICMP. So this is the guy that helps me to identify, that helps me to verify the connectivity between the PC1 to the PC2. But there's another problem. ICMP it's a protocol, which means it's a set of rules. So we need to take a help of another command under the ICMP that's called as a ping command. Ping stands for packet internet grouper. So ping is a guy, right, that works under the ICMP protocol. Ping is a guy that works under the ICMP protocol. So with the help of ping, we are going to identify, hey, do we have a connectivity or not? So what I can do that on the PC1, simply on a PC1, I'm just going to ask ping, right, 1.1.2, which is the IP address of the PC2. So I'm sitting on the router of PC1 right now, and I'm sending my data to the PC2. This is my source. This is my destination. Let's have a look. So I'm getting the reply. It means that don't worry about that. What is the TTL, bytes, times right now? You will get to know that each and everything. Just hold on. Okay, I'm just giving you the basic information. We'll do the detailed discussion about the each and every words over there. So right now you can see that when I send the packet for the ping 1.1.2 from the PC1, I'm getting the reply from the 1.1.2. It means that I do have a connectivity. Now let me show you in the depict format. So what I can do from the PC1, hold on. From the PC1, I'm sending the data to the PC2. Guys, please pay attention. This is the hub problem. See the problem of the hub. So this is my normal ICMP packet. If you just open this packet, click on this one, and you can see that this packet is the source IP address is 1.1.1. Destination IP address is 1.1.2, right? Source is 1.1.1, destination 1.1.2. Even you can see the layer 2 address. The layer 2 address, we have a 002. That's my MAC address of the PC1, right? And 0090, that's a MAC address of the PC2. Do you know what happened in that case? If I'm just going to capture and forward this packet, when this packet comes to the hub, what hub will we do? Hub is doing the broadcasting. My packet was sent from the PC1 to the PC2, right? But what happened in that case? When hub received the packet, it sent the packet to the PC2. At the same time, he sent the packet to the PC3 and the PC5 as well. After that, they are dropping the packet to the PC3. The reason is that in the what happened, we have a source IP address is 1.1.1.1.1, destination is 1.1.1.2, right? So when this packet comes to this guy, he's sending the packet to this person, and this person. So the PC5 is saying that, hey, you know one thing, my IP address is 1.1.4, your destination is 1.1.2. I'm not 1.1.2. Let me drop this packet. PC3 is also saying, hey, my IP address is 1.1.3. The packet that you're sending is for the 1.1.2. Let me drop the packet. PC2 will accept this packet. Can you see that? Because the IP address is 1.1.2 belongs to the same packet. Now, when the 1.1.2 will give the reply, try to understand, right? When he's giving the reply packet, it comes to the hub. Again, hub is doing the broadcasting. Again, the PC5 will drop the packet because in reply, what happened? In reply, 1.1.1.2 will be source and 1.1.1 will be destination, right? That will be the reply packet. When the PC2 will give the reply to the PC1. Normally, when you say the hello, right? Then your neighbor person also will say the hello, right? So when I send the request packet to this guy, he will send the reply packet to me. So when the reply packet also coming, the hub is doing the broadcasting. And that's a major problem. Wastage of bandwidth. Every time this PC and this PC will receive the packet. Not I'm talking about the wastage of bandwidth. Take example, how about if there is a if attacker is sitting over there, the attacker, the bad boy, right? If the bad boy is sitting over there, he can easily intercept all your information, whatever information you're exchanging between the PC1 and PC2. Whatever the data that you're exchanging between the PC1 and PC2, this guy can intercept all information. And that's a major problem of the hub. And that's why nowadays, nobody is using the hub. Another problem with the hub, do you know what? Another issue with the hub is what? Hub is a half duplex device. If somebody know half duplex, that's good. If somebody know, let me explain what is the meaning of half duplex. Half duplex means what? If I'm a receiver, right? He's the sender and he's the receiver. If I'm a receiver, so I'm receiving the traffic, right? I cannot send the traffic at the same time. Guys, please pay attention. I'm saying that, right? He's the receiver, he's the sender. If the sender sends the traffic to the receiver, if receiver is receiving the traffic, right? He cannot send the traffic at the same time. Bidirectional communication is possible. Some guys have the confusion. Okay, some guys I have seen that in the interview, they're saying, no, bidirectional communication is not possible in the hub, or we can say the half duplex. It's possible, it's possible. But only the problem is what? At the same time is not possible. When I receive the packet completely, right, then I can send the packet. But if I'm receiving the packet, right, if I'm receiving the packet, if the communication is happening between the PC1 and PC2, right, through the hub, no other person can communicate. No other person. Even he cannot send any data to the any person, not to this guy. Forget this guy. Even the PC4 cannot send any data to the PC3 even in the half duplex. Only one person at a time can send the data. Only one. That's the meaning of half duplex. Let me show you. Hold on. So what I can do that. So already my packet is going from the PC1 to the PC2. At the same time, what I can do, I'll send the packet from the PC5 to the PC3 as well. Have a look. Guys, pay attention right now. This guy, when I'm going to click the capture and forward, when I'm going to click on this guy, what happened? He will also send the packet. He will send the packet to this guy, and he will send the packet to this guy. When the packet will come to the hub from both the direction, the packet will be collide. See. Of course, right? It's a one-way communication. Hub is a what? Half duplex. Half duplex means what? Only one person at a time can communicate. If the PC1 is communicating with the PC2, no other person can communicate. Only the PC1 can send the, once the PC1 finish the data sending, then other PC can transmit the data. At the same time, you cannot transmit and receive, and no other user can transmit and receive the data. That's a hub problem. If they are doing that, then collision will occur. And that's why, because of this reason, hub has a single collision domain. Single collision domain is what? Only one person can at a time send the data. Once they will finish with the sending the data, then after that, other person can send the data and receive the data. If they are doing simultaneously, then collision will be occur. And that's why we have a single collision domain. It's a one-way, normal language. One-way means what? Remember, you have a one-way road. In the one-way road, what happened? If we are driving the car from this side, right? This is the guy who is driving the car. Another person cannot drive the car from the same another direction. If they are doing that, then you will have a collide. And if there will be collide, then what happened? There will be traffic jam. Same thing is happening in the networking. If there is a collide, right? What happened? After that, for the period of time, for the few minutes, what happened? You will have a traffic loss. in your network. And that's why it's not recommendation to use hub in the market nowadays. That's the biggest issue with the hub.
Hello,
Yep.
Saurav this here, sir.
Mhm.
Sir, half duplex means either we can send a packet, yeah, either we can receive the packet, sir. Receive या send at a time. Only one PC to one PC, sir.
If you're sending it, you're just sending it. The PC, so he's sending it and he's receiving it, right? Now the
Okay, sir.
PC cannot send it. If the PC2 is receiving it, he cannot send it.
Okay, means suppose, sir, I am discussing something with you. If I am talking with you, singly, sir, only I am talking with you. That is known as half duplex.
No, if you're talking to me right now, I'm only
Yes.
listening you. Okay.
Okay, okay.
I
Got it,
cannot
sir.
tell you something. Once you finish, then I can tell you something.
Okay, okay. Means one side communication,
One
sir.
side communication, right?
Sir, that
Okay,
is
okay.
walkie-talkie.
Yeah, you
Yes,
can
yes.
call, but normally in the walkie-talkie, I have seen that, uh, simultaneously I can, like, normally I recently, 6 months back, I had a conversation on the walkie-talkie with my friend, a normal conversation, right, in the flat only. So I'm doing that one. So, I can, so my friend is also saying, I'm also saying at the same time. So yeah, walkie-talkie is a very good example. I have seen that.
I think it's just like a pager, one-side communication.
Yeah. No. In the pager, what happened? Uh, I haven't used the
Yes, sir. Yes.
pager, but I cannot confirm that pager is a working like half duplex or not. I am not sure that. But walkie-talkie is a very good example of the half duplex. That's
Because I
only.
remember pager,
Sorry.
it was in
Personally, I haven't used the
1997.
pager. That's why I cannot confirm you there were the pager. But I have seen in the movie the pager is something like that. Once you send it, right? Then after that, if this guy is interested, then he will send the data to the another guy. But again, simple logic, half duplex means what? One-way communication. So if the communication is happening from this side, right? He's receiving it. Once PC2 done with the receiving, now he can send the data. If the PC2 is still receiving the data, still receiving it, right? In that way, no other user can communicate through the hub. No other user. Forget the PC2. No, even the PC5 cannot communicate with the PC3. That's a one-way communications. Now the next, to avoid this problem, right, one-way communication, right, that because you can see that there's a collision occurred, we have a solution, and that solution is known as a switch. Come on. That solution is known as a switch. Hold on. Let me delete something. Delete. That's good. Yeah, that's good. So let me connect the cable now again. Let me put the switch. So after the hub, the bridge was in the picture, right? But I cannot show you the practical of the bridge. The reason is that I don't have. But after the bridge, the switch came in the picture. So let's take a switch 2960. And now let's connect the cable. Different device we have. Can you see that PC1 and switch? It's a different device. It's a straight through cable, right? Automatically, you can choose this cable. In this one, what happened? Device can automatically detect, right, which type of cable I have to use. Otherwise, you have to choose the straight through as well. I'm so sorry. No, that's good, right? So we have a different interface. We have 0/3, 0/4. So 0/2 as well. Hold on, the spanning tree protocol is going on. I already have IP addresses configured over there, so there's no issue with the IP and the PC2 as well.
STP is only runs once when we on the switch, or it will run continue after connecting a new device.
The spanning tree is by default enabled, so it will continuously run.
Oh,
So now all good. Let me show you the one way of the beauty part. I'll just go on the PC one. Let's see first of all the connectivity do we have or not with all the PC. So as I told you that the protocol we have ICMP. Under this protocol we have a command ping. So ping is a command. Okay, it's not a protocol. Ping is a command that works under the ICMP protocol. Okay, ping is a command that works under the ICMP protocol. So ICMP stands for Internet Control Masses Protocol. Internet Control Masses Protocol. Ping stands for Packet Internet Broker. So whenever you're gonna verify the connectivity between the two devices, right? You can use the ping command. Ping adds the 1.2. I do have a connectivity, right? I can check with the 1.3. I do have a connectivity. It means that from the PC1, I do have a connectivity with the PC2. And from the PC1, I do have a connectivity with the PC3. Let's have a look at the PC4. That's good. Have a look, the beauty part. In the case of a hub, what happened? In the case of hub, let me explain you over here, or let me do it over here.
Hello, sir.
Yes, bro.
Uh, ping command or NSLOOKUP trace route.
देखो ये सब चीजें है ना, ट्रेस रूट जो हो गया, अगर मैं बहुत हाई लेवल पे बात करूँ तो ट्रेस रूट है ना यूडीपी पे भी काम करता है, समवेयर टीसीपी पे भी काम करता है, ठीक है? तो
Yes.
इसको अभी छोड़ ही दो तो बेटर होगा, धीरे धीरे पढ़ते हैं, we'll cover
Okay,
everything, don't worry about that, okay?
ठीक है.
So
Thank you, sir.
guys, pay attention right now. What I'm trying to see the PC1, PC2. I'll try to show you the difference between the hub and switch. So in the case of hub, what happened? If the traffic is going from the PC1 side, right, to the PC2, right? The traffic is going from the PC1 to the PC2, right? PC4 cannot communicate with the PC3 at the same time. No communication will happen. PC1 can send it, right? And PC2 can receive it. That's how the operation will work. PC2 can only receive it, and it only send it. It means that if somehow even the PC4 is trying to send the data to the PC1, it's not gonna possible. Collision will be occur. Single collision domain.
Hello.
Yes.
The collision means what, sir?
अभी तो दिखाया था यार. देख बताता हूँ क्या होता है. I'll tell you. Don't worry. I'll tell you. Just wait a
Okay,
minute.
sir.
Now, what I can do that right now on this one. Let me go in the graphics again and have a look. I'll put the packet from the PC1 to the PC2, right? I put the packet from the PC1 to the PC2. At the same time, have a look. I'll put the packet from the PC5 to the PC3. In the previous case, if you guys remember that, it was not work, right? But it's gonna work over here.
Yes, sir.
There's no collision is occur.
Okay, got it, sir.
Fine. Everything is working finally. All my communication is gonna work. That's a beauty, but in the case of hub, it was not working. Single collision, the meaning of single collision means what? You can only send it and another person can only receive it. That's a single collision. Other guy cannot send and receive it. But in this picture, in the switch, what happened? Switch has a multiple collision domain. Depend on the port. So if there is a 4-port, 4 collision domain. 5-port, 5 collision domain. So you can see that this guy has a separate collision domain. So there will be, of course, no issue. This guy has a separate collision domain. This guy has a separate collision domain. And this guy has a separate collision domain. But in the case of hub, what happened? Single collision domain. There will be have a 4 collision. There is a 4 collision domain right now. So that's a major difference between the hub and switch. Hub and switch allow you to have a LAN communication, but not the WAN communication. It only allow you to have a LAN communication, not the WAN communication.
Okay, sir.
Right, so that's all for the basic lab, guys. Okay, nothing more, because before starting the routing part and those things, my agenda is what from the Monday, right? From the Monday, we are gonna start with the subnetting. Okay, so well, feel
Sure,
free
sir.
subnetting for the A, B, C. We cannot do the subnetting for the class D, right? The reason is I told you the yesterday reason the why we cannot do the class D subnetting, right? Because for the class D, a single IP address is represent the particular group, right? So we cannot do the subnetting in the class D. We can do the subnetting class A and B, C. And then what I'm planning will do the start from the switching part. Switching in the sense of what? We'll cover the how the MAC address is learning, what is switch, how does switch MAC learn the MAC address, what is ARP protocol, right? What is the spanning tree, what is VLAN, what is DHCP, then Ether channel, like port security, then we you have what we call DHCP, those things. Once we have done with all the layer 2 part, right, then we'll jump to the routing part. That's my plan.
That's great. That's great.
Yeah, that's my planning, because let's go with the step-by-step layer 2 to layer 3, right?
Because
Okay.
switching, if we will cover it first, then we can easily understand the routing.
Routing part, right? That's my goal.
Sir, switching theory and practical is covered.
Both will be, don't worry, everything will be covered. So
Okay,
for the
sir,
next
thank you.
1 month, we are only gonna hit the switching part. 1.5 months
Yes,
almost.
sir.
So only gonna switch the switch part. We'll do all the labs and everything, with that. Okay. And
Yes, sir.
on every Friday, we'll try to do some books stuffs as well from the next Friday, not this Friday, right? From the next Friday, because my plan is what? From Monday to Thursday, we are gonna do the labs. Okay, labs and theory. And
Yes.
on a Friday, what we'll do some books stuff, right? Books stuff means I'll open the book in front of you, and we'll try to look for each and overview of the each chapter, right? So that in that way, what
Okay,
happens
sir.
at the end of the day, like once you finish the training, you are also able to finish the book as well.
Yes, good idea, sir.
So there
Very
will
good.
be some, like I have one question, sir. There will be like some production. You will create some, a topology which we can use in existing
Okay,
production or
let me pause the record.